Alright guys, so I welcome you to our today's lesson. We are going to do vectors. Okay, so the first thing you need to know about vectors, first of all, you need to understand what a vector and a scalar quantity is. Okay, because these things um, are used at the same time, sometimes may be confusing. Okay, but our main focus is on vectors. Okay, but I want to say something on what also on scalar quantity, so that you have an idea, because in multiple choice questions, those MCQ questions, you may receive uh, on differentiating scalar and vector quantities. Okay, so here I'll write scalar here, scalar quantity, and here I'll talk about vector quantity. Okay, so what you need to know about a scalar quantity. A scalar quantity, it is a quantity which we can define as the one which has only magnitude. Okay, it has a magnitude. Magnitude, guys, it is same as size. Okay, now a vector, it's going to be a quantity, it's going to be a physical quantity. Those physical quantities, guys, you know, like time, acceleration, those are physical quantities. Okay, now they are classified into two. They are scalar and vector quantities. So now vector quantities are these quantities now which have both magnitudes. Okay, they have magnitude here, they have magnitude and direction. Okay, so here are some of the examples I'm going to give you about vector and scalar quantity. On scalar quantity, let's try to talk about mass. Okay, about mass. Okay, so now mass, guys, mass, for you to define mass, you only need the quantity, you only need the size. For example, you can just say that a 2 kg of sugar. Okay, you can say a 2 kg of sugar. You don't need to tell the direction of sugar, where that mass of sugar is. There is no way you can define mass like that. You only need what? The quantity. Okay, but when it comes to things like for example, we can give force. Force is a vector quantity. To define force, yes, it must have a magnitude in any size, for example 2 Newton. Okay, but which direction? Okay, but which direction? We are going to say, for example, east. So you can tell to say this force, this quantity has got a magnitude, it has a size, it has also what? Direction. Okay, other quantities you need to know which are scalar quantity. Let's talk about time. Okay, time also, you can, time has only what? Has only magnitude. There is no direction with time. You can't say that time is moving in the east direction. That can't happen. You can only tell to say we have what? We have taken 10 seconds there, or 10 hours. You can't say that 10 hours are moving in this direction. No, that can't happen. Okay, but quantities like weight as magnitude. Okay, it has magnitude. It is also measured in Newton. Let's say, for example, 4 Newton. You know that mass acts downward. It can act downwards. Okay, we know that weight, it is the force which acts what? Downward. So this mass as what? As a direction. Okay, I mean weight as what? As a direction. So this is how you differentiate. This is how you differentiate the two. Let me try to see somebody. Somebody saying is failing to join the meeting. Okay, so other examples, guys, other examples. Now these other examples I'm just going to give so that you may know. For example, here we have work. Work or energy is a scalar quantity. We have things like temperature. Temperature has no direction, guys. Temperature. We have distance. Okay, distance. There are a lot of things. When we talk of speed, these have no direction. Okay, but here when we talk of displacement, guys, this is just a recap of grade 12 work. I can't take a lot of my time on explaining this because you won't be asked even a lot of question about this. We talk of acceleration, it's a vector quantity. My main focus is on vector quantities. Okay, let's talk of momentum. You are going to learn about momentum. Don't worry what momentum really means. We're going to learn about momentum. Weight, I've talked about weight. Okay, so these are some of what? These are some of vector quantities which you need to know. Okay, these guys, I was telling them to go in campus. Okay, so now let's go ahead and talk about how we can add. Okay, how we can add parallel vectors. Okay, here is what I want you to see. A vector, guys, it is represented by an arrow. Okay, it is presented by an arrow, and this pointed arrow, guys, this part where it is pointed, it is what we call the head of the vector, and this end here, it is what? It is the tail. You need to know this. Okay, so now this question, the question you will receive in this kind of a question, parallel vectors, these are vectors which are in the which cannot meet. Okay, these vectors cannot meet as long as these vectors will continue moving like this. Okay, it can be in the same direction or in different direction. Vectors like this going up, the other one going down, these vectors will never meet no matter what. Okay, so how do we add these vectors? Okay, so here is the question. Find the resultant vector and its direction. Okay, so the resultant vector, guys, it is what? It is the vector which we found by adding two or more vectors, and it is represented by the capital letter R there. Okay, so now how do we add vectors which are pointing in the same direction? As you can see, these vectors are pointing in the same direction. So when two vectors are pointing in the same direction, the resultant vector is found by adding the two. Okay, so we're going to add 200 Newton there plus 100 Newton. So our resultant vector is going to be 300 Newton. Okay, what about the direction? Because what we've just found, it is the magnitude. What about the direction? The direction now, we are going to follow the halo. Okay, when you go at the compass, it looks like this. Okay, this is how the compass looks like. Sorry, the compass looks like this. Okay, here is our north, here is our east, here is our south, and here is our west. Okay, so as you can see, the vectors are going, both vectors are going in the east. So the direction of the resultant vector will be what? Will be east. You just need to say east. This is how you find the direction of two vectors which are pointing in the same direction. Okay, these concepts are very simple. Okay, so this these concepts are very simple. In fact, I may only accept questions as we proceed. I'll allow you to ask. You have a question? Hello? Is there a question? Okay, so I'll be recording videos in segments. Okay, so what about these two vectors? Okay, we can name this to be vector A and this to be vector B. Okay. Now look at this. These two vectors, they are pointing in a different direction. This one is pointing to the east and this one is pointing to the west. Okay? So how can you find the resultance vector? So to find the resultance vector, guys, since they are pointing in a different direction, we subtract. So there is somewhere where there is some noise. Please mute your mic. Please may you just mute your mic. Okay, so when we subtract these two vectors, we are going to get 20 Newton there. Okay, because they are pointing in opposite direction, we subtract. Now the question is, which direction are we going to follow? Because vector A is moving in the east and vector B is moving in the west. So we are going to follow the direction of the bigger vector. Okay, so this vector which has a bigger magnitude, it is the one which we are going to use for what? For the direction of the resultance vector. So the resultance vector is going to move in the direction equivalent, okay, or in the same direction as the what? As the bigger vector, which is vector A, and the resultance vector is going to be 20 Newton and the direction east. This is how you find it. This is how you find the direction. Okay. Now I may accept a question here, just two questions. Do we have a question or we don't have? These things are very simple, guys. So we proceed. Okay, let's talk now about these two vectors. Okay, this vector is moving in the east, this one is moving in the west. Okay, and we know that this one is bigger and this one is smaller. So the resultance vector will move in the west direction to follow this vector which is bigger as usual. So what we are going to do to find the resultance vector, we are going to subtract. Since they are moving in the opposite direction, we're going to say 50 Newton minus 20 Newton there. So the resultance vector now is going to be 30 Newton. This is the resultance vector. Now the direction we follow this one, which is going to the west because it is bigger than a 20 Newton vector there. Okay, so we say that the resultance vector will move what? In the west. So the west is. Do we have any question, guys? Speak up, please. This is just an introduction. There is a lot to talk about. That's why I'm trying to move faster. Okay, so we move. What about these two vectors? Okay, as usual, these vectors are parallel. As you can see, this one is moving south and this one is moving north. Okay, so this one is a 150 Newton vector and this is a 125 Newton vector there. Okay, so as you can see, you can even tell to say that our resultance vector is going to go south because south, I mean this vector, a 150 Newton, which is moving south, is bigger than what? Is bigger than the vector which is going in the what? In the north direction there. So what you are going to do now to find the resultants vector, since they are in opposite direction, you subtract. You are going to have 150 minus 25, which is going to be 25 Newton there. The direction will be south. Okay, so let's do now this question. We have two questions. We have A and B. Okay, but they are just we are going to use the same scenario there. Okay, so the first question is to find the resultants vector. You also find the what? The direction. Okay, as you can see, 33, this vector which is going west is 33 Newton, and this one is 33 Newton. Also, this one is 20, and also this one is 20. So I want you to know this. When adding two vectors which have same magnitudes, okay, same magnitudes, but opposite in direction, this is what you need to take note. And I'm sure you guys have got calculators, because I don't have a calculator with me here. So when two vectors are moving in the opposite direction but they have equal magnitude there, the resultants vector will always be 0. Okay, the resultants vector will always be 0. These vectors are going to cancel out. It is same as 33 minus 33, which is just going to be 0, guys, here. So same applies to here. We have 20 Newton and 20 Newton, same direction and same magnitude, but moving in the opposite direction there. So the vector are going to cancel out. Since they have cancelled out, they are not going to have a what? A direction. It's like we don't have a vector which is remaining. That's why the resultants vector is going to be 0. Shad, just reduce for me a volume.
Is that enough finish?
No, it was finished. Okay, so if this part, guys, is important. Yeah, I like telling you this one is important. You need to know. And I have a question where we're going to apply this concept. When two vectors are equal in magnitude but opposite in direction, the resultants vector will always be 0. You may be given a force, and you are asked to find another force which will make the resultants force to be 0. Just give the same force, but with what? With the opposite direction. Very simple like that. Any question? Sir, ask please. Sir, madam, I don't know. Mind you, guys, this is not a presentation, it's a lesson. We interact.
We interact. We are moving together.
Alright, thank you.
Thank you.
Okay, so here is the question. So when you are reading this book, I was talking about college physics 11th edition, you'll find the things like quick quiz here. Don't skip these questions. Are the one which are going to be part of your MCQ questions. Okay, so the question reads, the magnitudes of two vectors, vector A and vector B, are 12 units and 8 units respectively. What are the largest and smallest possible values for the magnitude of the resultants vector? I'm receiving an echo there. Okay, so to find the result, the largest vector, we have been given vector A. Vector A is 12 units. Then vector B is also 8 units there. So how can you find now the largest vector? Okay, The largest possible value of the vector will be found by adding the two. That's how we find the largest vector. Okay, so the largest value of vector r will be found by adding 12 plus 8, and you are going to get 20 units there. What about the smallest? The smallest now is going to be found by subtracting. We subtract, so we are getting 12 minus 8 there, which is 4 units. So according to the option which have been given, that means C is the what? Is the right what? Is our correct answer there. So this is how you deal with any questions which are involving adding or subtracting vectors. Okay, so let me check if there is still another question there. Alright, so on adding, on addition of vectors using graphical method, okay, how do we add vectors? Take note of this. We add vectors from head to tail. This is how we add vector. So from where the vector is going to end, from where the first vector is going to end, it is where the other vector is going to start. Okay, I always
I have a question, sir.
ask.
I wasn't clear about those first one. When you subtract, it gives you a zero. What is the direction there?
It has no direction because the vector has cancelled out. It is like 0. 0 is nothing. There is nothing which has remained.
Okay, I get. Thank you. Continue.
Alright, sir. Thank you too. Okay, so I was saying the vector is represented by an arrow. Okay, and this pointed part of an arrow is what we are calling the edge. Okay, and here is the one we are going to call the tail. So what we do, we add vectors from head to tail. So if the first vector is moving like the way hair is moving, the other vector to add another vector to A, we are going to start at the point where our vector A is ending. That's where we are going to draw another vector. Okay, so let's say for example I've been given vector A which is moving like this arrow which is in green. Okay, like this arrow which is in green. Also we have also been given this vector which is vector B which is also in green, and it is moving. It's like it is moving at an angle here. As you can see, it is not in the straight line, it is moving at a certain angle. How can you add the two vectors? Okay, adding the two vectors, the only number first you add from head to tail, then you follow the order according to how the question is given. So let's say for example I've been given to find A plus B there. Okay, what is our A plus B? Using graphical method. So graphical method, guys, doesn't require us to do any calculation. We just go ahead and add vectors. So the first thing, we are going to start with A because our A is the first vector which has been given there. Okay, we draw A like the way it is. Okay, we draw A here. We even name it to be our vector A. What else? We are going to draw now B. Okay, but B is going to start from where vector A is ending, from the edge, okay, from the head of vector A there. So here is where we are going to draw our vector B there. I may not be so accurate in drawing lines. Okay, so this is going to be our vector B there. I'm just drawing vector B like the way it is here, as you can see. okay, but it's starting from where A is ending. This is our vector B. Now, what you are going to do next is to connect the two lines, okay? You connect the first point here from the tail to the head of vector B. To the head of vector B. Okay, so this now is the resultant vector. This line connecting the two is the resultant vector, which is A plus B. Guys, if you miss this concept, then you are going to find a lot of challenges with dealing with vectors. Okay, so I just want to finish this part, then I want to admit others who have requested to join. Okay, this is how you had vectors. Let's say for example, what if we have been given now B plus A? B plus A. Okay, in mathematics you've been told to say addition is commutative. 2 plus 1 is 3 and 1 plus 2 is also 3. It is commutative. But when it comes to addition of vectors, yes, the fact remains the same, but the diagram is not going to look the same because we are going to start with a B instead of a A. And here is how the vector is going to look like. Okay, so as usual, we have vector A, which is looking like this. This is our vector A, and our vector B is like this. Okay, so now what we are going to do, guys, we are going to draw vector B because we are finding now B plus A. Okay, we are finding B plus A. So what we do, we draw vector B in the first place like the way it is. This is our vector B. There is noise somewhere. Please guys, mute yourself. I've been telling about muting yourself since we started. So this is vector B now. Okay, this is vector B. Now, as usual, we had the vector from edge to tail. So vector A is going to start from here, and it's going to be exactly like the way vector what? Vector A here is. So it is going to move in this direction. You even aim to say this is vector A. So what you do next, you just connect the two lines. Okay, you connect. So this is now our resultant vector, which is vector B plus A. Any question? Any question so far? That means there is no question. Okay, now how do we subtract vectors now using graphical methods? It is one and the same. We subtract also vectors from edge to tail. Okay, from edge to tail. So now, but here is the trick part. Okay, let's first find A minus B. Okay, so A minus B, what we are going to do, guys, we are going to draw vector A like the way it is. Okay, we draw vector A there. This is our vector A. This is our vector A. What about vector B? We know that we had vectors from edge to tail. That's why drawing vector A, we would have drawn vector A going up here like the way it is if we had plus A. Okay, but because of negative A, negative is telling us now to shift. This vector is going to move in the opposite direction. This is the concept you forget. If we have a negative, the vector is going to change direction. Okay, it is going to change direction. So our vector B is now going to come this direction. The same way it is, but it's just going to change direction. Okay, so we are even going to connect the two lines now. Okay, we connect the two lines. Sorry. I have problem with writing lines there. So this is now going to be our resultance vector here, which is A minus B. The key concept, when we have a minus, change the direction of that vector which is being affected by the negative. Okay, if it was minus A, guys, if it was A which are the negative, this vector would have moved in this direction. Now that's a simple logic which is here. Okay, so let's do also another question to find now B minus A. Then I'll allow you to ask questions. How can you now find vector B minus A? How? We already know that our vector A is like this and our vector B is our vector B is like this. Let me draw my vector B to be here. This is my vector B here. This is my vector A. Okay, so now how are we going to find B minus A? So since we are starting with B here, we're going to draw B like the way it is. We draw like that. Okay, what else now are we going to do? We are going now to find negative A there. Okay, so negative A, you know that A is moving in this direction. Now because of this negative, our negative A is going to move like this now, in the opposite direction to what? To the positive vector. So this vector now, to draw now, the vector is going to move like this. This is our what? Our vector A now. So you even connect the two lines. At least this I've tried now. You connect the two lines. You have the resultance vector to be, this is our B minus A. Okay, so guys, ask me questions now before we start solving questions on addition of vectors using graphical method. Ask me questions. We want to finish this part so that the
Give an example.
is disturbing me.
Give an example.
There is no question, guys.
I'm saying, just give us an example.
Hello?
Examination question about this.
Okay, this is what you are going to do next. How am I going to solve this? Okay, here's the question. The question reads, find the sum of two vectors by using a graph. This is our goal. This question is coming from the same textbook I'm telling you, and that book you should make sure you solve all examples for you to be safe. Okay, so vectors, like I said, it involves the motion in a statement, but you are going to convert that into what? Into a diagram. That's how you'll be handling any question on vectors. You'll be given a statement like this. Okay, so the first statement is a car travels 20 kilometers due north. This is our first point. Okay, the car is traveling 20 kilometer due north. So if it is traveling 20 kilometer due north, it means it was moving in the north direction there. Okay, and it covered 20 kilometer. This is our first part you need to know. So here we are going to treat this as our north. Okay, as our north here as our west as usual, here our east, and here as our south. So the first or let me read the question first, then I'll show you how to go about it. Okay, so a car travels 20 kilometers due north and then 35 kilometers in a direction 60 degrees west of north, as in figure 1.15. Okay, I removed the figure. I'm going to show you the figure. I want to show you how to find this. Okay, using a graph, find the magnitude and the direction of a single vector that gives the net effect of the car's trip. Okay, this vector is called the car's resultant displacement. So there is some necessary information which are in the question, just because it is an example. Okay, so this question is all about finding the resultant vector using graphical methods. Okay, so what our first motion, it is that it moved 20 kilometer due north. Okay, so we're going to draw the line there from the origin here all the way to where we can estimate here our 20 kilometer is going to be here. Okay, so it moved this direction. Okay, you can even draw to this to be, like I'm telling you, I'm not very accurate when it comes to drawing. So this line, guys, how am I going to change this? Okay, let me write maybe here. This is our our first vector moving north here, 20 kilometer there. Okay, what is our next part? Our next part now, I've been told to say that it moved now 35 kilometer. Okay, 35 kilometer in the direction what? In the direction west of north. Okay, when they say that the vector is west of north, listen this, west of north, it means that that vector was between north and the west. Okay, so this vector, we will now move from, we know that the vector ended here. Okay, the vector, the car first ended here 20 kilometer. So now it is going to move in the direction west of north. Okay, west of north at 60 degrees. So this vector is between west, okay, and north. This is what it means, and the vector is going to move like this. Now, where are we going to put our vector? When you say west of north, it means that the vector, the angle is closer to what? To north. So our 60 degrees is going to be here. This is where we are going to put our 60 degrees here. Okay? So here, so that I'm failing to draw this line, but here we have also the first vector which moved north here. Let me maybe put dotted lines. At least you can see something here. I'm going to show you the clear diagram. Okay, so now we know that here it moved 20, so you can, here you just estimate, guys. Okay, you can put, if you want, you can put negative 20. So since here on the x or y plane we have negative there, we have negative 40 here. Okay, so now to find the resultant vector which they are asking for, we connect the two lines from where the vector started there, from where the car started moving to where it ended. We draw the line here. We draw the line connecting the two. They maybe change the color. Okay, so we just draw the line there. is the only part I suffer too much. It is drawing the line. My pen is very sensitive. So you guys, we are going to write a straight line there. What is important is to get the information. So this is now going to be our resultance vector, this part here. Okay, so this is how you show what? This is how you show the car's resultance displacement. By just showing this, the first was going north at 20 kilometer, the second was going west of north. It is between west and north. Here, as you can see, we can estimate that this vector now moved 35, and you can see that 35 can be somewhere here. You don't need, somebody asked me, do we need to have protractors and compass to measure the accurate angles? Actually, no. Okay, we don't need those instruments here. You just estimate. So our 35 can be somewhere here. Okay, so this is how simple now you do this kind of equation. Let me hear from you. Let me see, or let me first show you this. So this is what actually I was talking about. This is the first vector. You can name the first motion as it moved 20 kilometer north. Okay, it moved 20 kilometer there, 20 kilometer north. That's why you can see the first vector is reaching here at 20 kilometer here and in the north direction here. They used the compass here. Now the second motion, it was moving now west of north, but at an angle of 60 degrees. That's why I was saying here you have our west here, and on top here we have north. When you say that the vector is moving west of north, it means it is in between west and north. Okay, it is in between west and north, but the vector is closer to this. I mean, the angle is closer to north than west. That's why, as you can see, our 60 degrees is closer to north here than to what? To west here. So you even draw this vector. That's why this vector moved in this direction now. Okay, in this direction. So connecting the two from this point to where this point ended here, this is the what? The resultance vector. Now you can ask, guys, before I proceed to the other question, which is the last question, then we proceed to other parts. We are almost using up 1 hour, so I don't know if you are going to finish.
We are moving together.
Hello?
We are moving together.
All right, thank you. Okay, so this is now from sheet 2 physics 101. The vector A has a magnitude 8 units and makes an angle at 45 degrees with the positive x-axis. Okay, I'm taking these points. 45 degrees with the positive x-axis, and it has a magnitude of 8 units. Okay, then vector B also has a magnitude of 8 degrees, I mean 8 units, and is directed along the negative x-axis. Okay, so what you need to know is that now we are asked to find the resultance vector using graphical methods. Okay, using graphical method. So we're going to find first A plus B. Okay, so here is our positive x-axis, here is our negative x-axis, here is our positive y-axis here. Here is our negative y-axis. Okay, So now the first question is find by graphical method vector A plus B. So as usual, we are going to draw vector A. Vector A, we have been told that it is making an angle of 8 there. It is making an angle of 45 with the what? With the positive x-axis. Okay, so we draw here. We can draw something like this. Okay, this is the positive x-axis. That means the angle is between the vector and the positive x-axis. We can name this to be 45 degrees, like that. So this is our vector A there. You name it. This is our vector A. Now, vector B, guys, vector B now is moving in the negative x direction. Okay, when it's moving in the negative x direction, it means it is going in this direction. Here we haven't been given an angle. If you haven't been given an angle, guys, just know that the vector is moving as a straight line there. It is moving in the straight line. Now going in the negative x direction. Okay, and we know that the other thing which you need to know now is that we had vectors from edge to tail. So we're going to start our vector from here all the way to this point. This is where our vector B is going to be. So connecting the two lines, we are having now our hair plus B. Very simple, guys. Okay. So now, anyone with the question before I answer A minus B? Guys, you need to be asking me. I want to know if you have a question or not. Okay. So, as usual, A minus B is not affecting A because A is still positive. What is being affected is B. Okay, you rent this. Okay, so our vector A will still be the same, like the way it is from this point all the way to this point at 45 degrees. But B is now negative. It is going to change direction. Instead of it moving in the negative x direction, it is going to move in the positive x direction. Because of what? Because of this. Okay, because of what? Because of this negative here. I was saying that the negative will affect the vector to change direction. So we're going to have the vector B moving in this direction. Okay, this is our vector B. So you even connect the two lines. This is going out to be our sorry, it should be our hair minus B. This is making more sense, guys. Vector B just changed direction. Vector A is maintained here. So I'm answering all these two questions on the what? On the same axis. Okay, but you can answer separately if the question is requiring you to answer separately. So you can even include the units if you want. From this point, the first vector is moving 8 units. So the other vector will move more 8 units. So it will read at 16 there. Since both are of a magnitude of 8 units. As simple as that. Any question? Girls, any question, please? You haven't asked any question since we started. Okay, since there is no question, that means on adding vectors, we just end here. Okay? We are going to do another part which is very important, guys. If you are dozing, you must pay total attention with what you are going to start